Jai Hind students. In the series of these complex topics of telemetry principle, now we are going to concentrate on the fourth unit complex topic. As you know that in telemetry principles, fourth unit is about the transmitters and the receivers, and for the transmitter and receiver, antenna is a very major component, because when you want to use any telemetry system in wireless mode, this antenna plays a very important and crucial role for the whole functioning of the telemetry system. So before going towards the type of antenna or something else, I want to give you some basic description about the what is antenna. Actually, when you want to talk about the basic antenna definition, an antenna is a device that provides a transition between guided electromagnetic waves in wires and electromagnetic waves in free space. Means, if you want to consider a normal example, that if this is a normal wire and if you applied any type of voltage across this, as I am using my this hand to hold this wire, so it means I am providing some type of power from this end to this conducting wire. So now what will happen? As soon as you provide any type of power here, three phenomenon going to take place in this conducting wire. First one is whether that all power applied here is going to be consumed by this wire, or the complete power which is applied at this wire is going to radiate in the environment, or if there is not properly matching at the end of this wire, then that complete applied power will be reflected back towards the source again. So these three phenomenon are going to take place. But when we are talking about antenna, what will happen? If you applied any power to a conducting wire, then that power will be converted into the electromagnetic waves due to the radiation property of the wire. Because you can see here in this diagram, this is a transmission line. You know that transmission line having two different lines in the parallel combination, and you are going to apply a generator here. As soon as you applied a generator here, the waves follow this guided medium through this transmission line, and at the end, if you widen this transmission line or as a particular shape, these guided EM wave or this applied voltage will radiate in the environment into the form of electromagnetic waves, because at the end this transmission line is open and this applied voltage is creating a electromagnetic field inside this transmission line, and that electromagnetic field will create electromagnetic waves. So you can here see that antenna is a passive electronics device which is going to convert the applied voltage into the electromagnetic waves. So if we want to talk about the antenna as a transmitter or receiver, the antenna single-handedly work for both transmitting or receiving ends. How it is possible? Because antenna actually follow the reciprocity theorem. Reciprocity theorem. What is that reciprocity theorem? Reciprocity theorem says that if you applied any voltage, then it will radiate in the environment in the form of electromagnetic waves, or if you put a conducting wire inside a electromagnetic field, then that due to that electromagnetic field, a voltage is induced at the end of the antenna. Means either you applied the voltage or you put that wire into the electromagnetic field. In both cases or in the both direction, the antenna will work. Means the antenna is used same as transmitter or receiver. So here you can see that when you are talking about the electromagnetic waves, there are two fields, that are magnetic field and electric field, and they both are perpendicular to each other, and the propagation of the wave is just perpendicular to both of these fields. Means if you follow this right hand rule, if this is the direction of magnetic field and this is the direction of electric field, means that propagation direction is in this direction. So you can here see understand how the antenna is going to function. So these are some kind of antenna which are used by the telemetry system, in which this is a Yagiuda antenna, this is a patch antenna or patch antenna array, because this is one is a single patch and here you are using a 4 patches, means a group of patches. Similarly, this antenna you see in the mobile towers, and that are basically phased array antenna. Similarly, this is parabolic reflector antenna, this is your dish TV antenna which is going to be used at your home. So these all are the basic antenna, and you can you are using all these antenna in your daily life. So when we are talking about antenna, basically that is about antenna, but when we want to describe what is antenna actually in technical terms, then we need these fundamental parameters of a antenna. So when we are going to design any antenna, these various 13 or more than 13 points are required to define an antenna. So if I am going to tell you about the most basic kind of antenna, so if you are designing an antenna of f frequency, f hertz frequency, then what is the length of antenna? So as per the hertz, the antenna length is lambda by 4, means minimum length of antenna lambda by 4, means if the frequency of the antenna the frequency of the signal which is used by the antenna is f, then correspondingly its wavelength is lambda. So if we want to find out the length of the antenna, then that length of the antenna is equal to lambda by 4, means the just for minimum you have to require, if your signal wavelength is 4 mm, in that case the minimum antenna length is required is 1 mm. So this is about the basic antenna designing. So other than that, we are having also other points, and you have to consider all these points, because these all points are asked by the university examination, such as 2 marks question, or sometimes it is a higher marks question, such as frequency and frequency band, radiation pattern, field region, directivity, efficiency and gain. And in these parameters, this radiation pattern, directivity, efficiency, gain, impedance, and these are the very important topics which continuously asked in the previous examination. So when we are going to consider all one by one. First of all, frequency and frequency band. Actually, the complete frequency range is divided into this 3 Hz to 790 terahertz frequency band, and all this frequency range is divided into various different frequency band, and that band name are as ELF, SLF, means extremely low frequency, super low frequency, and so on, visible spectrum. So these all individual bands are going to be used for a specific application, such as extremely low frequency are used for underwater communication, super low frequency are used for AC power, whether very high frequency used for FM radio, ultra high frequency for television, and super high frequency for the satellite link or extraterrestrial communication. So these all are the application of various frequency bands, and here you can see that as soon as frequency is increasing, the wavelength is decreasing, means as soon as frequency increasing, your length of the antenna or size of the antenna is also decreasing. So this is also an important part, because you all also using the modulation part, and that modulation plays an important role to short the height of the antenna. Similarly, second point is radiation pattern. So here you can see a radiation pattern. So here question arises, what is that radiation pattern? If you are applying this antenna here, and if you going to check that what is the radiation intensity or radiated power around this antenna, and you want to plot it on a 2D or 3-dimensional diagram, then this radiation pattern come into the picture. Means radiation pattern is a 3-dimension geometrical representation of the radiation intensity around the antenna. Here you can see that this is the Z direction, whether this is the X and this is the Y direction. Here you can see that you are applying a dipole antenna here along the axis of the Z, and here you can see that this is a donut type structure in which you can see that along the XY plane the radiation intensity is maximum, but as soon as you go far from the antenna, then that radiation intensity is only for a given distance, and at the axis of the antenna, which is in the Z direction, there is no radiation. So here you can see that this donut type structure only possible in the 3-dimension representation of radiation pattern, but when you are talking about the 2-dimension, this picture came into the picture. Again, here you can see that this is a 3-dimension but 2-directional radiation pattern, but when you are talking about this is a unidirectional radiation pattern. Means when you are talking about the radiation pattern, here you can see that in this radiation pattern there are various you can see here that there are various types of antenna as per the radiation pattern, and that are unidirectional antenna, bidirectional antenna and omnidirectional antenna. This is a bidirectional antenna, this is a unidirectional antenna, and omnidirectional antenna means if you are going to apply a antenna here and if its radiation pattern is a sphere, it means that is a omnidirectional antenna. Here you can see that this is the main lobe. Main lobes means the direction of maximum radiation, and other also lobes are present. These all lobes are called side lobes, but if that side lobe in just in the reverse direction of the maximum radiation, that is called back lobe, or otherwise other lobes are known as side lobes or minor lobes. So these are the radiation pattern. Here you can see that the frequency domain representation of that radiation pattern, and this is the major lobe, side lobes, back lobes. Then the field region. Basically antenna create field in three regions, that are reactive near field, radiating near field or Fresnel region, and third one is far field or Fraunhofer region. So then we are going towards the directivity. Then directivity is a fundamental antenna parameter which is a measure of high directional antenna radiation pattern is. Means antenna that radiate equally in all direction would have effectively zero directionality, and the directivity of this type of antenna would be 1 or 0 dB. So it means directivity is technically a function of angle, but the angular variation it is described by its radiation pattern. Means in a particular direction how much the radiation intensity is, that is described by the directivity. Similarly, an antenna that radiate equally in all direction would have effectively zero directionality, the directive function of angle. Then the efficiency of antenna. Then second point is antenna efficiency. The efficiency of antenna relates the power delivered to the antenna and the power radiated. It means antenna efficiency is directly related to, if you are given an antenna X power and the radiated power is Y, then the ratio between the X, Y is the antenna efficiency. So these all are the point related to the antenna design. Then the gain. The term gain described how much power is transmitted in the direction of peak radiation. Means if you are going to apply the apply the power into the antenna, the directivity is only about the directionality of the antenna, but how much the power delivered in that direction of peak radiation, that is defined by the gain. So there is a difference between gain and directivity, and also there is a reflection that is D is equal to neta G, that is also directivity and gain ke beech mein, that is the relation in term of efficiency. Then the beam width and the side lobes, that is about the that is come from the radiation pattern, between the angle between the points of the radiation pattern, that is beam width. That beam width come from the various points that are 3 dB. How you can understand that? This is the main point where antenna is located. This is the radiation direction. Here the antenna having the maximum radiation, it means 1 dB. But here is the point where the power of the radiation is became half. That is known as minus 3 dB point. And at this 3 dB point, where we draw a angle between this the cut down position of this radiation pattern and this line, a point came that is known as half power point, and the angle between that half power point is known as half power beam width, which decide the width of the beam. So other than that, antenna impedance and bandwidth are also the another parameter of antenna designing. In antenna impedance, you know that is a related to the antenna resistance, and it is a complex quantity where x plus jy, and the bandwidth is about the range of frequencies over which the antenna can properly radiate or receive energy. Similarly, now we are talking about the isotropic antenna, because whenever we are talking about the antenna designing or finding out the gain or direction of the antenna, we always have to take a reference antenna. And practically there are many type of antennas, but actually when we are talking about a ideal antenna, that ideal antenna is known as isotropic antenna. Basically ideal antenna is a hypothetical antenna which is basically a point source, means all energy which you provide that point source is radiated in all direction equally. That's why the radiation pattern of a isotropic antenna is omnidirectional, means this is the point, means this is the radiation coordinate system. Here you are putting that point source, means the radiation pattern is in the form of sphere and it is going to radiate in all direction equally. So that is about the isotropic antenna. Then the first very practical antenna, that is dipole antenna. That dipole antenna is basically having the length of lambda by 2, means if wavelength is lambda, then the length of the antenna is lambda by 2, and it having a radiation resistance of 73 ohm. And this dipole antenna having actually a current distribution along a dipole roughly sinusoidal. So as far as university exam is concerned, the question always ask about the what is directivity, what is gain, what is efficiency, and also sometimes they ask some 5 marks or 7 marks question, describe or explain the dipole antenna used for the telemetry system. So here you can draw these diagram and also write down these points. I am here mentioning all the main bullet points of this dipole antenna. Then this is the radiation pattern. If you are taking a normally lambda by 2 antenna, then this is the radiation pattern. This is in the 3 dimension and this is in the 2 dimension. But multiple dipole antenna is also possible, and that dipole antenna is just as a multiple of lambda by 2. If you are using 2 dipoles, means lambda total length, then the radiation pattern will become this. If you are using 3 lambda by 2 antenna in combined, then it will become a 3 lambda by 2 antenna, and the radiation pattern is this in the 2D and in the 3D. Similarly, this dipole antenna having the use of various such as RF antenna. Also, this is the theoretical maximum gain and Hertzian dipole, or the maximum theoretical gain of lambda by 2 dipole here shown. Similarly, this is the 3-dimension radiation pattern for a dipole, and this is the another example of another diagram of a 3-dimensional radiation pattern for a dipole, so that you can easily understand this geometry. Then types of dipole antenna. Basically types of dipole antenna are short dipole, half wave dipole, quarter wave monopole, and folded dipole. When you are talking about short dipole, that is having the length is less than lambda by 4. Half wave dipole is lambda by 2, quarter wave is lambda by 4, and folded dipole when you are going to make a folded type structure as shown in diagram. You can here see that this is the folded dipole antenna, in which you are taking a lambda by 2 length antenna and folding it from the end, and now providing the power to this input point. So this is the folded dipole antenna, and this having a folded dipole antenna advantage is increase in impedance and wide bandwidth, and this is the radiation pattern of folded dipole, and it is used for VHF FM broadcast and domestic television. So antenna array. Similarly, here you can understand one point, that a single antenna have some limitation in its gain and directivity. If you want to increase the directivity or the gain of a antenna, sometimes you use a set of similar or dissimilar antennas in a group, and that group form a antenna array. So why we can use this antenna array? Basically to increase the overall gain, provide diversity reception, cancel out interference from a particular set of directions, also state the array so that it is most sensitive in a particular direction, and determine the direction of arrival of the incoming signal if you are using it in a receiving antenna, as a receiving antenna, and also to maximize the signal to interference plus noise ratio, SINR. So these are some basic requirement of antenna array. So this is also a making question at the university point of view. Similarly, there are two types of antenna array, and that are parasitic and driven array antenna. So parasitic array antenna used for controlling radar and various other narrow beams such as microwave communication system, where driven array antenna radiating elements are connected to an energy source and have less loss when compared to parasitic array, but still maintain the narrow beam characteristics, are used as search radar antenna, where narrow beams are less critical when compared to a low losses. So these are some kind of antenna array that are collinear array, broadside array, end fire array, parasitic, Yagi-Uda, log periodic, turnside. These are other different type of antennas. So here, if you want to understand, you have to understand this broadside and end fire antenna array maximum, because the basic these both are the most common type of antenna array. What is going to happen in this broadside and end fire antenna array? You are taking similar antennas, set of similar antennas such as this. If you are going to provide power to all of these antenna in same phase and same magnitude, it will become a broadside array. But if you are taking a group of antenna and providing the power opposite in phase but same in magnitude, it will create a end fire. This is a end fire, this is a broadside antenna array. These are the most common type of antenna arrays. Then this is the antenna array where we is going to use. These all are the application of antenna array, such as fire radar, missile guidance, weather research uses, radio frequency identification, Yagi-Uda use for TV, then log periodic antenna, broadcasting, for the beam forming, naval uses, optical phased array. These all are the utilization and application of antenna array. Then Yagi-Uda antenna. Yagi-Uda antenna is again a group of antennas, means it is a antenna array, and in what is going to happen, this in this antenna, here you can see that this is the Yagi-Uda. Here you can see that this is the feeding point, this one is the feeder, this one is the director, and this one is the reflector. Actually you will get the radiation in one direction only. Basically when you are going to understand here, what is going to happen, this is the axis, here you are going to put that antenna, and how you are going to take that, this is the, these are directors, this is feeder, and this is reflector. All this radiation will came in this side, because only the source is applied here only. In this direction the radiated region will add on, whether in this direction, that will cancel out. That's why the radiation take place only in this direction. Then microwave antenna. These are the another type of antenna which is widely used by this telemetry systems, such as horn antenna, parabolic reflector antenna, slot, dipole, dielectric antenna, printed antenna, phase array antenna. So starting from horn antenna. Horn antenna are basically used for microwave frequencies such as 300 megahertz to 3 gigahertz and higher frequencies. How it is going to create? Here you can see that. For microwave, you use guided medium, and that guided medium is a waveguide. This is a waveguide. This is a waveguide. And here you can see that this waveguide helps the microwave signal, which is actually having a electromagnetic wave, in a guided medium. So what will happen? This is the E direction and this is the H direction, means this is the magnetic field direction and this is the electric field direction. So at the end, same as the discussed in the starting of this antenna, you understand here one point. If you are going to widen the end of the waveguide in E direction or E plane, then it will create a E plane horn antenna. Or if you are going to widen this horn antenna in the H plane, it will become a H plane horn antenna. If you are going to widen this waveguide in both direction, it will create a pyramidal horn antenna. You also know that waveguides are also possible circular waveguides, and these circular waveguides can also make conical horn antennas when we widen the end of this waveguide. These all antennas are used for the microwave range. Similarly, the parabolic reflector antenna. When we are talking about the parabolic reflector antenna, its name suggests its basic working mechanism. Basically, parabolic reflector antenna work on the parabola geometry principle. You know that if this is a parabola and this is the focus of the parabola, if any rays are coming from this focus, that will become parallel to the axis of the parabola after reflecting back from the parabola curve. And if waveform are coming parallel to the axis of the parabola, then after reflecting back from the parabola curve, that will concentrate on the focus of the parabola. This same mechanism is used in the parabolic reflector antenna. Here we are having two types of antenna. First one is primary antenna and second one is secondary antenna, or primary radiator or secondary radiator. In this diagram, actually this is the primary radiator, this is the secondary radiator. What is going to happen? This primary radiator is a normal antenna such as horn antenna, dipole antenna or some kind of other. You are going to apply the voltage here, that will create electromagnetic waves. That electromagnetic waves will directed towards this parabola structure, and after reflecting back from this parabola structure, these waves will be directed in the direction and parallel to the axis of the parabola. Similarly, if it is a receiving antenna, then the waveform coming from the distance as focused by this parabola structure to this primary antenna, and in the same case this parabolic reflector antenna used as a receiving antenna also. So here comes its directional pattern. So here by this directional pattern you can easily see one point, that parabolic reflector antenna, which is used for microwave and higher frequencies, is highly directional in one direction, and that direction is toward the axis of the parabola. So this is the use of the parabolic reflector antenna in telemetry. Similarly, the last one is helix antenna. Basically, helix antenna is a structure of helical wire, and that helical wire is made such kind of that it will create a normal helix antenna, which is used for the extraterrestrial communication. And here you can see that this is a conducting wire. If you make this wire in the straight mode, it will become a dipole. If you make some turns and with a specific diameter of helix, spacing and number of turns, it will create a helix antenna. So helix antenna will work in two modes. First one is normal mode and second one is axial mode. When it is in normal mode, it will work just like a dipole antenna. You can see that this is the 3 dimensions radiation pattern of the helix antenna in normal mode, and it is same as dipole antenna. But when you are talking about the axial mode, in the axial mode, this same antenna will be very directional in one direction, and that will make this antenna used as a extraterrestrial communication purpose. So basically all these antenna are used by the telemetry system as they required in the transmitter and receiver. And when we are talking about the university question paper, these all questions are coming as per the antenna desired, and the most basic questions are such as define the directivity of antenna, define the gain of the antenna, define the efficiency of antenna, or explain the parabolic reflector antenna, dipole antenna, or phased array or antenna array or Yagi-Uda antenna. These are the most important question as far as AKTU university examination point of view. So this is all about the complex topic of 4th unit, and in the next class we will discuss about the 5th unit complex topic. Till then, thank you.